So what does it say? So a small indoor greenhouse, okay, is made entirely of glass panes, including base, held together with tape. Okay, it is 30 centimeter long. This so that is it is a form of cuboid, as you can see, right? So length is given, which is 30 centimeter. Breadth is 25 centimeter. Height is again 25 centimeter. So basically, it's a greenhouse which is made up of glass and it is in the shape of cuboid. So like this, right? So this is length, this is breadth, and this is height. What is the area of the glass? So including the base is written. That means you have to take the base also. So that means total surface area of the cuboid you have to find, right?
Yes, ma'am.
Okay, so part one, area of glass. So area of glass is equal to, uh, just 1 minute, yeah. Yeah, so area of glass is actually surface area of cuboid. Understand? See, when I write only surface area, it means total surface area. Okay. And when we write lateral surface, so then we mention lateral surface. So that means we are avoiding the base and the top. So here surface area means total surface area, or you can write total surface area of cube, which is equal to 2 into LB plus PH plus HL. Now just put the values and find. So 2 into LB, that means 30 into 25 centimeter square. Okay, because I'm multiplying two lengths which are in centimeters, so it will become centimeter square plus BH, that means 25 into 25 centimeter square plus HL, 25 into 30 centimeter square. Okay, so 2 into just multiply. So okay, 0 I can write, and then 3 into 5 is 15, carry 1, 3 into 2 is 6, and 1 7. So 750 centimeters square. 25 into 25 is 625. Okay, plus again 25 into 30 is 750 centimeters square. Now you can add them. So 2 into, just do it separately to avoid mistakes, right? Okay, so 5, 5, 5, 10 into 12, carry 1, 7 and 7, 14. Okay, and then 14 and 6 is 20 and 1 is 21. So 2125 centimeters square. Now multiply by 2. So 2 into 5 is 10, carry 1. 2 into 2 is 4 and 1, 5. 2 into 1 is 2, 2 into 2 is 4. So 4250 centimeters square is the total surface area of the glass which will be used. Yes, Zeba, written?
Yes, ma'am.
Okay. Okay, Jesslyn is not here today. Right. Now part second. How much of tape is needed for all the 12 edges? Okay, how will you do it? Now again see carefully. This is a cuboid, right? And this side is L. This I'm denoting by B, and the height is H. Okay. Now they're asking how much tape is required. Now tape are applied at the corners here at the edges when we are joining the two glass panes. Understand? So that means this whole length we have to calculate, like every side we have to calculate the length of each side. Understand? So
Yes,
this,
ma'am.
okay, so this purple is your tape basically, if you can see that. So anyway, so this is simple. One front face, if you see, front face means this is L and this is L, right? The top is also L. And then this is H and this is H. So 2L plus 2H. This is the length of the tape required, right? You can write like this, length of tape required. So for front face, 2L plus 2H, right? Is that clear?
Yes, ma'am.
Okay. And same for the back face, 2L plus 2H. Now left face. So left face, one side is B, so that means 2B and 2H. And similarly, your right face, same 2B plus 2H. Then you come to top. So top, that means this side is L and this side is B. So again, 2L plus 2B. And also the base, 2L plus 2B. So this is the total length of the tape required, as you can see. Is that clear?
Yes,
Okay. So total length of the tape required is equal to. Now simply add them. What else you can do, right? So very carefully, just write 2L plus 2H. Okay, put brackets plus 2L. Okay, two times it is occurring anyway. Just write first of all. Then you have 2B plus 2H plus 2B plus 2H plus 2L plus 2B and plus sorry, 2L plus 2B, right? Okay, so this bracket is coming two times, so I can write 2 into 2L plus 2H. Any problem? Again, this bracket is two times, so 2 into 2B plus 2H, right? Plus 2 into 2L plus 2B. Is that okay? Now, okay, so this 2, now another 2 I can take common. So 2 into 2 will become 4 and it will be L plus H. Similarly here, B plus H. And similarly here, 2 common, so 4 into L plus B. Understood now?
yes, ma'am.
Okay. Now you take 4 common, so it becomes L plus H plus B plus H plus L plus B. Okay. So 4 into, now there are 2L, so 2L plus 2B plus 2H. Now you can again take 2 common, so 4 into 2 and it becomes L plus B plus H. So that is 8 into, now you can put the values of length, breadth and height. So your length is 30 centimeter, breadth is 25 centimeter and height is also 25 centimeter. So 8 into, okay, so 25, 25, 50 and 30 is 80. So 80 centimeter and 8 into 8 is 64. So 640. No, what I have done here is What is the answer at the back of NCRT? Can you tell me that?
Yes, ma'am. Next question. 320 centimeter of tape.
320. Okay, I have got my mistake. Okay, there is one mistake I have done here. Now, see. Okay, sorry. Now when I'm taking the faces. So what is happening here? For example, if you look at this side, for example, this side, right? Right. Now, if I just call it AB. So this side is actually part of front face also, right? And this side is part of base also. Understand? So
Yes, ma'am.
when I'm writing the, so basically I have counted this side 2 times. Understand? That was my mistake. I mean, in the front face also, I have included one L, right? And the same L I have also included in the base. So basically, this L is counted twice here. Understand?
Yes, ma'am.
Yeah, so that was my mistake. So I think I have to do this part again. Please cut it. Sorry. So all this calculation. So I mean, this actually the extra factor of 2 which is coming, this should not come. Okay. Anyway, do it again. It's not that tough. So just make a cuboid. So let me give it some name. That way I think it will be easy to name. A, B and C, D, right? And the back faces I'm calling P, Q, R, S. Is that clear now?
Yes, ma'am.
So let us name it this way. So length of the tape required. So there are how many sides? 1, 2, 3, 4, right? 6, 7, 8, 9. Then no, sorry, 8. Sorry, 4 and 4, 8. Then 9, 10, and 11, 12. So there has to be 12 edges here. So one by one, let us write. So AB plus BC plus CD and plus AD. Is that okay?
Yes, ma'am.
Okay. Then plus, now the back face, let us write. So PS plus PQ and plus QR plus SR. Okay. Then, so this AD and PS are already included, only this is left. So this is left and this is left. So PD plus AS, right? And similarly here, QC is remaining and RB is remaining. So QC plus RB. I hope it's understood now.
Yes, ma'am.
Okay. Uh, so AB is, so instead of putting up direct values, you can write it in terms of LBH. It will look a bit simpler, right? Now AB is L plus BC. Where is BC? BC is height plus CD is again L and plus AD is again height. Okay. Plus PS. PS is again height. PQ is L. QR is again height. And SR is again L plus. Now PD is base. AS is also B. And QC is also B. And RB is also B. Is that clear now?
Yes, ma'am.
Okay. Now you can see 1, 2, 3, 4 lengths are there. So 4L plus 1, 2, 3, 4H are there and plus 4B are there. So take 4 common. So length plus height and plus breadth. So that means 4 into, again, this was 30 centimeter plus 25 centimeter plus 25 centimeter. So that is 4 into, okay, 80 centimeter, and 4 into 8 is 32. So that becomes 320 centimeter. So I hope the mistake you have understood.
Yes, ma'am.
Okay.
Done, ma'am.
Next question then. Now, Shanti Sweets stall was placing an order for making cardboard boxes, okay, for packing their sweets. Two sizes of boxes were required. The bigger of dimensions and the, okay, some dimensions are given. So we can just note for bigger box. So length is 25 centimeter, breadth is 20 centimeter, and height is 5 centimeter. Then smaller box also we can note. Your length is 15 centimeter, breadth is 12 centimeter, and height is 5 centimeter. For all the overlaps, 5% of the total surface area is required extra, okay? If the cost of the cardboard is this, find the cost of cardboard required for supplying 250. Okay, that is the second part of the question. Let us stick to the first part. So we are interested in basically the total surface area of the box, right? That will give us the length of the cardboard, the area of the cardboard. Is that okay?
Yes, ma'am.
Okay. So let us find total surface area of bigger box according to these dimensions. And then we will add 5% extra area, because when we make boxes, we take some extra portions which are actually folded inside and like that. So there's 5% of extra cardboard required. No problem. Total surface area of bigger box. Simply formula put LB plus BH plus HL, which is 2 into length is 25 and into breadth is 20 centimeter square. This is 20 into height is 5 centimeter square. 5 into 25 centimeter square. So 2, now 25 into 2 is 50. So that is 500 centimeter square. 20 into 5 is 100 centimeter square. And 5 into 25 will be 125 centimeters square. So 25 into 4 is 100 and extra 25, so 125. And then, yeah, just add them. So 500, 600, so 725 centimeters square. Now you multiply. So 2 into 5 is 10, carry 1, 2 into 4 and 1, 5, 2 into 7 is 14. So 1450 centimeters square. Right? Now extra area required. Extra area of cardboard basically, right? Area of cardboard which is required is actually 5% of this TSA of bigger box. Understand?
Yes, ma'am.
So we find 5% of it and then we will add it. So 5% means 5 upon 100 into this 1450 centimeters square. So 1 0 cancels out And so you multiply by 5. So 5 into 5 is 25, carry 2. 5 into 4 is 20, and that 22. 725 divided by 10 centimeters square. So that becomes 72.5 centimeters square. Understand?
Ma'am, how did you got that 725 answer by 10?
Okay. So I have just 1450, right? Now 10 will be cancelled out. And then I have multiplied 5 into 145. So I have got 725 and then one extra 10 in the denominator. And then I have put the decimal.
Okay, ma'am. I got it now.
Yeah. My habit is actually not to disturb the zero of the denominator. So it's better to multiply and then put the decimal back.
Done, ma'am.
Okay. So that means the total surface area required for one bigger box equal to. So TSA required for one bigger box, right? So will be equal to uh, the total surface area and plus extra area required. Understand? So the total surface area we have found, which was 1450 centimeters square. And the extra area is this 72.5 centimeters square. So just add them. So 0.5 will come here and then you have 2. 7 and 5 is 12. Carry 1, that becomes 5. So 1522.5 centimeters square. Yeah.
Yes, ma'am.
Okay. Now how many boxes are there total? You can just multiply here itself. 250 boxes of each kind. Okay, so this was the TSA for one bigger box. Let us find TSA for 25 bigger boxes. Okay. 25 bigger boxes will be equal to simply 25 multiplied by 1522.5 centimeters square. Is that clear?
Yes, ma'am.
Yeah. Okay, so here you just have to multiply. What else you can do? Please multiply this and tell me what are you getting. Sorry, it was 250 boxes, right? Not 25. One more zero will come. Okay, so at least this zero will go. Just wait. So if you remove the decimal, so 15225 and then divided by 10, right? So this zero at least will cancel out. So 25 into 15225 only. Now please multiply and tell me.
Ma'am, the answer is 380
Mm.
26 625.
380625. Said, I hope it's correct. 625, okay. Now the same steps we have to repeat for the smaller box, right? Okay. Now TSA of a smaller box. So this will be 2 into LB plus BH and plus HL. 2 into, how much was the length? Can you just tell me? Smaller box was Yeah, it was 15, 12, and 5, right? 15, breadth was 12, and height was 5 centimeter. Okay, so let us just put the values. So length is 15 into 12 centimeters square plus, just check, am I right? Just check the
Yes,
question.
ma'am.
Okay, BH. So 12 into 5 centimeters square plus HL. This is 5 into 15 centimeters square. Okay, 2 into, so you have to multiply this. Please multiply 15 into 12. 2 into 5 is 10. Carry 1. 2 into 1 is 2 and 1, 3. Sorry, 180 I'm getting. Am I right? 180 centimeters square. 12 into 5 is 60 centimeters square. And 15 into 5 is 75, right? Centimeters square. Now add them. So 2 into, okay, so you have 5 and then you have 8 and then 6. So it becomes like 24. And then you have 7. So that becomes 31. So 31, that carry 3 and then 1, 4. Am I right? No, I think I should add properly 180, 60 and 75. So 5, right? Now this is 14. 14 plus 7 is how much? It will be 21 and then 2. So 315, sorry. 315 I'm getting centimeter square. And then multiply. So 2 into 5 is 10. Carry 1, 3, 630 centimeters square. Right? Okay. Now extra area required. So that means it is 5% of TSA of smaller box. Right? So this is 5 upon 100 multiplied by 630 centimeters square. So 1 0 will cancel out. It will be 5 by 10 into 63 centimeters square. Now multiply the numerator. So 5 into 3 is 15. Carry 1. 5 into 6 is 30 and 131 divided by 10 centimeters square. So that becomes 31.5 centimeters square. Okay.
Yes, ma'am.
Okay. So total surface area, what we say, total surface area required for one smaller box. So that will be equal to TSA of smaller box plus extra area required. Now TSA was 630 centimeters square. Extra area is 31.5 centimeters square. So this becomes 0.5 will come here and 1 will come here. 3 and 3 is 6 and this is 661.5 centimeters square. So this is for one smaller box. So total, okay, so TSA required for now 250 smaller boxes. So this will be equal to 250 multiplied by this 661.5 centimeters square, right? So 250 into 6615 and divided by 10 centimeters square, right? So this 0 will cancel and just multiply by 25 and tell me the answer quickly.
Ma'am, the answer is 6640.
6640? No, it should be a bigger number. See, you're multiplying 6615 into 25. Should be at least, I think, 5-digit number, 6-digit number.
Ma'am, the answer is 165375.
Okay. So this is PSA of 25 to 50 smaller boxes. So that means now the total cardboard required. Let us find out. Oh, really lengthy question, right?
Yes, ma'am.
Total cardboard sheet required. Okay. So cardboard sheet required means area of 250 big boxes and plus area of 250 smaller boxes, small box, right? So that we have already calculated. Okay, what was that area? Bigger box. So bigger box, it was 380625 centimeters square, right? And the smaller we have just found 165375 centimeters square, right? Now add them. I hope I have written it correct. The first one. Please check 380625. Now add them. So 5 and 5, 10. Carry 1. 8, 9 and 1, 10. Carry 1. 9 and 1 again, 10. Carry 1. So 6, 8 and 6, 14. Carry 1, 4, 5. So I'm getting this. So this is 54600 centimeters square. Please make a habit of doing calculation with your pen. Okay, don't use any calculator.
Okay, ma'am.
Yeah, otherwise, you know, there's no point of doing all this calculation. The purpose of this, let's say, chapter is to make you, where to make you able to do calculation fast and accurately. And if you are using calculator, there's no point of solving questions here.
Yes, ma'am.
Hmm. And in the exam, then you face difficulty. When you don't have a habit of doing calculation, then you make mistakes. Okay, anyway, so this is the total cardboard sheet required. Now there was something else in the question which was given. Just 1 minute. Yeah, okay, now see again in the question. See, at least this much we have done. Okay, now if the cost, come to the cost part, right? So if the cost of the cardboard is rupees 4 for 1000 centimeters square, and then you have to find the total cost for this much area which we have calculated, 250 boxes of each kind. So here for 1000 centimeters square it is rupees 4. Understand?
Yes, ma'am.
So we write like this, that cost of 1000 centimeters square cardboard sheet is equal to rupees 4, right? This is given to us. So that means cost of 1 centimeter square cardboard sheet will be 4, sorry, rupees 4 divided by 1000. Clear?
Yes, ma'am.
And then we have this much centimeter square. So cost of 546,000 centimeter square cardboard sheet will be 4 upon 1000 and then multiply by this number into this 546,000. This is in rupees. Yeah.
Yes, ma'am.
So this is equal to rupees. Now all the 30 will cancel out. It will be simple 4 into 546. And this is equal to rupees. So 4 into 6 is how much? 24. Carry 2. 16 and 2 is 18. Carry 1. 20 and 1 is 2184 rupees I'm getting. So this is the cost of cardboard sheet required for 250 such boxes of each kind.
Done, ma'am.
Okay. Okay, the last question now, question number 8. So Praveen wanted to make a temporary shelter for her car by, okay, Parveen, not Praveen. Okay, so Parveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin that covers all the four sides and the top of the car. Okay, with the front face as a flap which can be rolled up. So I hope you understand it, right? So basically it will look like this. Something will look like this. Sorry. Like something will look like this. And this part, this portion can be rolled up. This front face, it's like a flap. Okay, assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of height this with the base dimension? So base dimension is given. So the base will be same as the top, isn't it?
Yes, ma'am.
So base dimensions, if you want, you can write like this also. So base dimensions is equal to 4 meter into 3 meter. Okay. And height is given in this question 2.5 meter. So basically what is given? Your length is 4 meter, breadth is 3 meter, and the height is 2.5 meter. Okay. So we have to find the area of the cuboid minus the area of the base. Understand?
Yes, ma'am.
Okay. So area of tarpaulin required will be so basically it will be PSA of cuboid, total surface area of cuboid, and minus area of base or bottom. Yeah. Okay. So this we know, this is 2 into LB plus BH plus HL, right? Minus area of bottom. So what will be the area of bottom? Length into breadth, right? See, this is height. Bottom means just length into breadth. Understand?
Yes, ma'am.
Okay, so minus 1 LB. So LB you have to minus here. Hmm. So you can put the values here also, or you can, okay, anyway, so this is 2 LB plus 2 BH and plus 2 HL and minus LB. So 1 LB will be gone. So it is only LB and plus 2 BH and plus 2 HL, right? Now let us put the values. So what was that? Length is how much? 4, right? Breadth is 3 and height is
2.5.
2.5 meter. Okay. So this is 4 into 3 now meter square plus 2. This is 3 into 2.5 meter square. 2 into height is 2.5. L is 4 meter square. Okay. So 4 into 3 is 12 meter square plus. So 2 uh, 2 into, so 3 into, now remove the decimal first, meter square plus 2 into 25 by 10 into 4 meter square. See, this makes the calculation even more simpler when you do like this. So 12 meter square plus 2 into, now you can multiply. So 25 into 3 will be 75. So 75 divided by 10 meter square plus 2 into, now 25 into 4 is 100. So 100 divided by 10 meter square. So 12 meter square plus, so 2 into 75 is 2 into 5 is 10, carry 1, 2 into 7 is 14 and 115. So 150 divided by 10 meter square plus, okay, so only 10 is remaining now. So 2 into 10 meter square, right? 10 is gone. So this is 12 meter square plus, now 0 cancel out, only 15 meter square and here 20 meter square, which you can add easily. Okay, so 5 and 2 is 7 and then 2, 3, 4. So 47 meter square I'm getting. Yeah.
Yes, ma'am.
So I think only this much was asked in the question. How much? Yeah, okay, fine. How much is the tarpaulin required? So this is the answer.
Done, ma'am.
Okay, so the next topic is, so far we have learned about the area of cube and the area of the cuboid, right?
Yes, ma'am.
Okay, so the next figure is, 1 minute, let me open your book. Okay, it's a right circular cylinder and then you have, okay, so the next is right circular cylinder, the next exercise. No, 1 minute. Sorry, actually I open a PDF, sometimes it takes time to open. Right, so the next exercise is on a right circular cylinder. Let us try to understand what is it. So you know what is a cylinder looks like, right?
Yes, ma'am.
Okay, now what is the meaning of right circular cylinder? Now let us understand. So basically in this exercise, you have to deal only with the right circular cylinder, not any other kind of cylinder. If I want to form a cylinder, uh, for example, I have 50 coins, right? I start placing them like this. I place a coin, then I place, another coin on top of it, another coin on top of it. So ultimately I get a shape which is like this, isn't it?
Yes, ma'am.
So that becomes a cylinder. Now, What happen if I place one coin like this? Okay, another coin slightly outside, then another coin slightly outside, then here, I'm doing like this. They will not fall, you know that, right? So ultimately, I get a figure which looks like this. Is it a cylinder?
Yes.
Yes, it is a cylinder, but it is not a right circular cylinder. So you understand now. The right circular cylinder is one where the radius of the base circle and the height of the cylinder are actually perpendicular to each other, 90 degrees. Understand that?
Yes, ma'am.
So this is called a right circular cylinder. So if you call, if this is your R and this is your height. So basically in a right circular cylinder, your height is perpendicular to R. So only this type of cylinder you have to use in this chapter. Okay, so let us find the, okay, so now let us come to our circular cylinder, right circular cylinder. So we have to find its area. So there are two parts in this cylinder. One is this top, right? Another is the bottom of the cylinder. And then you have this curved uh, part also, right? So there are two types of area. One is the curved surface area. And then we have total surface area. So I think you need to draw a figure like this and just mark what is your R and what is your H in this figure. So this R is this, the radius of the base, and from the center of the top and to the center of the bottom, this is your height H. So the curved surface area of the cylinder is 2 pi R into H. Now from where you are getting, the circumference of the circle is 2 pi R, right?
Yes, ma'am.
And then you are just multiplying it with the height. So you get this complete, curved surface area. So this is 2 pi RH. Now I want total surface area. So total surface area will be nothing but curved surface area and plus top area and plus bottom area, right? So curved surface area is 2 pi RH plus. Now what is the area of the top? See, the top looks like a circle, isn't it? Whose area is pi r square. Yeah. And also the bottom is also pi r square. So 2 pi r h and plus 2 pi r square. This is the total surface area of a right circular cylinder. And this is the curved surface area. Right? So in book it will be written like this. You can take 2 pi r common and then you have r plus h. So this way also you can remember, but it's the same thing, right?
Yes, ma'am.
Yeah. Okay, so one question at least I think we can take. So exercise 13.2 now, and it is also written that you have to use pi 22 by 7 unless stated. Okay, in some question, if it is given that use 3.14, then you will use 3.14. Okay. Now the curved surface area of a right circular cylinder of height, this is this. So height of the cylinder is 14 centimeter and curved surface area is given, which is 88 centimeters square. Find the diameter of the base of the circle. Okay, no problem. CSA, that means 2 pi RH is given, right? So,
Yes, ma'am.
okay, so 2 into 22 by 7 into r, you don't know, height is given, which is 14 centimeter. This is 88 centimeter square. So take everything on the right hand side, keep your r here. So 7 into 88 centimeter square and divided by 2 into 22 into 14 centimeter, right? So as you can see, 1 centimeter will be gone and only 1 centimeter will remain. So the radius will be in centimeter, right? Okay. Because it's a length, it has to be in centimeter only, not centimeter square. Okay, let us just simplify. So anyway, this is, if you cancel from 11, so this will be 2 times and this will be how much? 8 times, right? And then 2 into 1 and 2 into 4. Then you have 7 into 1 and 7 into 2. And this 2 into 2 and 4. Everything will get cancelled out here. So radius is 1 centimeter. You can check your calculation.
Yes, ma'am.
Now you have to find diameter. Yeah, so diameter is 2 into radius. So 2 into 1 centimeter. So that is 2 centimeter. Diameter of base. Right, so it is required to make a closed cylindrical tank of height this and base diameter is this. So height is 1 meter. Base diameter is 140 centimeters. So be careful, you have to convert it. Okay. How many square meter of the sheet are required? So in meter, you want your answer. So you convert this, right? So again, milli, centi, deci, meter, deca, hecta, kilo. Okay, so you want to go from centimeter to meter. So that means 1 step, 2 step. So 140 divided by 2 zeros. Sorry, now it will be in meter. Understand? You are going towards a bigger unit, so you will divide. Understand?
Yes, ma'am.
Okay, so 1 0 is gone, and this is uh, okay. Keep it like this because you want radius. So radius is d by 2. So further divide this by 2. So 140 by 100 and into 2, right? So now what has become? So 1 0 is gone, and this is 7 by 10. So this becomes 0.7. Sorry, it is in meter now. Okay, when you have already divided, so it has to be in meter now, right? Okay. So radius is 0.5, 0.7 meter. Understand? How,
Yes, ma'am.
how many square meters of the sheet are required for the same? So it is a closed cylinder. So that means total surface area you have to find, right? So area of sheet required is equal to TSA of cylinder here. Total surface area of cylinder, right? So this is the curved surface area, which is 2 pi RH plus 2 pi r square area of top and bottom. So 2 pi r you can take common, it will become r plus h. So 2 into 22 by 7 into radius is 0.7 meters. Then you have 0.7 meter plus height. How much was the height? 1 meter. So 1 meter. Okay, so 2 into 22 by 7 into, remove the decimal, so it will be 7 by 10 Okay, meter. Now here, this will be 1.7 meter. Clear?
Yes, ma'am.
Okay. So 2 into 22 by 7 into 7 by 10. Now I'm again removing the decimal. So 17 by 10 and meter into meter, it will be meter square. Now you can cancel out a few things. So 1, 7 you can cancel and the rest you can multiply. So this is 44 into 17 and divided by 100 meter square. So quickly multiply. 7 into 4 is 28. 28 into 2 is 30. And 1 into 4, 1 into 4. So 8, 4, and 3 and 4 is 7. So 748 I'm getting here. Am I right? So
Yes, ma'am.
748 divided by 100 meters square. So that becomes 7.48 meters square.
Done, ma'am.
Okay, so now you have to repeat all the questions in the homework. Do the calculations on your own. And I will also send you one assignment. Please complete that. Okay, when is your exam? It's on
It's on 12th December.
12th December. So can we have a test on Saturday of some previous chapter?
Okay, ma'am.
Which chapter? Polynomials?
Okay, ma'am. Actually, one Sunday we have polynomials test in school.
Sunday. So better you have a test on Saturday then.